Good evening, everyone. So my name is Shin, one of the co-founders of Augmentus, and we are a spin-off from this institution, ARTC. We were founded several years ago in 2019, and our objective is to democratize robot programming. So as we all know, ROS is meant for developers, for people who are very familiar with programming, like Python, C++. But how about operators in the factory who are not very familiar with all these codings and technical robotic stuff? So we set off, and this is our mission. So we set out in 2019 to solve this particular problem of robot programming hurdle that faced by a lot of the factories. So when we speak to a lot of the factories, customers and so on, so they can have a system integrator that develop a solution for them, and then they deploy. What happens after that? What if they need to reconfigure the system? What if their operators doesn't know how to do the reconfiguration, doesn't know how to do the programming? Then what will happen? So therefore, the three of us, I was from A-Star, a tech lead, and then with the two other founders, Daryl is from business, and then Wu is our CTO, together with advisors. One is Gray Orange. He used to be an AI robotics startup that raised $180 million before, as well as Joyce, head of Unity business unit. So the reason why she's an advisor to us because we primarily uses Unity 3D to do robot simulation. So what we are setting out to do is that right now there's few methods, right, to program robot. You can have a teach pendant, you can use lead-through programming, or you can use offline simulation software like ROS to do the robot programming. But all of these methods requires high expertise. You need someone that knows programming, you need someone that's familiar with the robot. And each and every robotic brand have their own programming language that makes it difficult for the engineers. So a lot of times it is very long time for a factory owner to configure the robotic system to cater to a high-mix production environment. So we understand that ROS uses movie to do kinematic simulation, motion planning, and it primarily uses C++ and Python. It's a very powerful solution, and we have a lot of experience with ROS. We use ROS primarily for validation and simulation. However, how we extended our solution is to compile it into a tablet form. That makes it easier for the end user to use inside the shop floor. Because a lot of times, if you're in the actual production environment, you know that the production environment, the shop floor is very sweaty, it's very cramped, it doesn't have a lot of free tables around, doesn't have access to a PowerPoint everywhere. So we compress everything to make it a portable tablet system that we can actually use it. So we are a SaaS spin-off, but at the same time, we are the official Go technology partner of Rockwell Automation. That means that on our system, we not just can program and simulate a robot, but the user can also simulate the PLC as well. And our solution is actually downloadable from the iOS Apple Store. So the user just simply go to Apple Store, find Augmentus, and they're able to download and use our device to simulate a robotic system. How we work is that we use a scan and plan methodology. So all the user needs to do is just use a tablet, do a 3D scanning of the workpiece and the robot cell, and use the 3D scan as a basis to do robot motion planning. We use the basic digital waypoints. At the same time, they can simulate, for example, reachability, singularity, and collision. And after the simulation is satisfactory, all they need to do is just, with a one-click button, we will send it to the robot as a remote deployment. So our total solution exists as a standalone tablet solution with a 3D scanner mounted on the back. So everything is very portable, very easy to use inside the factory. I'll show you a video of some of the customer use case. So this is a sandblasting. So the user takes a tablet, go inside a sandblasting cell with an 8-axis system, that means inverted ABB robot with a turntable and linear wheel. And then with a 3D scan, they can just shape the areas they want the robot to do the blasting. And we will automatically generate the motion for them that is specific to their process parameters. So you can see here, just all the user needs to do just shades different areas and we generate the motion, cater to their needs. So the entire simulation of the linear wheel, the turntable, and the inverted robot is all within the tablet itself. And we'll generate the robot-specific codes. In this case, it's ABB. We generate rapid, and then they can actually, we click one clear button, we send it over to the robot through TCP, IP, and FTP. So our aim is to dramatically cut down the programming time because before Augmentus, they need to spend a few days for the operator to teach the waypoints. For every which waypoint that they teach, they need to actually measure the distance and the angle. So imagine there are hundreds of waypoints, it actually takes them a considerable amount of time to teach it. By using our solution, they can do it very quickly. We also expanded our solution to do welding applications. So this is not ABB robot, this is a China brand, a China robotic brand. We also extended our solution to do polishing of injection mold. And then lastly, surface coating as well. So the robot movement for surface coating, you need to actually do the edge bending to coat around the edges before you coat the center part. So all of this can be actually done through our software with a scan and plan methodology using a tablet only. So we are catered for different use cases. So we have customers that use us for polishing, inspection, sanding, spraying, media blasting, as well as welding. We also have customers such as ST Aerospace, ST Land, Hyundai, DJK, Johnson & Johnson, then abrasive engineering, and so on. Then we also, the primary way that we distribute is through system integrators, like Infinity Robotics in the US, Autoline as well. And we also have a strong partnership with some of the robot OEMs like ABB, Rockwell, Universal Robots, and Mitsubishi. So we do have extensive collaboration with the ROS institutions. So first one is we have collaboration with ROS-I Singapore on some of the projects. So I can't disclose the customer and also can't disclose the exact nature of the project. But I can give a description of how we collaborated with a ROS institution. So the institution used Augmentus as a way to take pictures using the tablet and use the pictures generated to annotate different SKUs inside to build AI model. So we used to have an inbuilt AI model generator that the user simply just use an iPad, take a picture, annotate, and then generate AI model. And the AI model is able to synchronize with the robot simulation environment that we have to do inspection and pick and place. But what happens after that is that in the middle of this year, we depreciated that functionality because we realized that actually it's actually quite costly for us to have a cloud-based AI model building system. That, so because it takes actually a few hours or even days to train an AI model. So when we try to scale it up to different customers, we realize that we actually incur more cost than profits as we try to scale it up. That's why for now we depreciated it, and we plan to actually reinstate the AI model building with robot simulation at the start of next year. Another collaboration that we have is with Open Robotics. So Open Robotics, they use RVs to simulate the robot environment. So they use us as a way to do a rapid 3D scanning of the robot cell. And using the robot cell, they're able to actually create coordinate frames inside the 3D scan on our solution. And we send over the coordinate frames to the RV's environment through TCP/IP, so that they cut down on the time to use the CAD files to rebuild the environment. Because we understand that when you use a CAD file, sometimes the CAD file may not be a true representation of the actual environment. It could be due to mechanical loading of the parts after it's gone on site. Parts may deform, may change shape, but when you use a 3D scanning, the user doesn't care about whether the CAD files are accurate. You just use whatever as is and scan and derive the coordinate frames accordingly. So we do have these existing collaborations with ROS-related institutions. So this is an example. So they did a 3D scan using a tablet, and then we are able to help them to localize the position of the robot by what we call the auto detection. And after the calibration is done, then the actual position of robot relative to the 3D scan is derived automatically. And we use something we call the Datum Spears. And we recognize the Datum Spears in the 3D scan to serve as a reference frame. And then what happens is that the user can select points in the 3D scan they want to derive the reference frame or the coordinates. And after that, they can just send it to their own RVS environment or ROS environment to use it for their own applications. So even though we have been using ROS for validation for quite a while, because we wanted to use, because all the robotic simulation, kinematics, motion planning takes place inside the tablet. So we don't actually use movie to simulate, but we view movie as a golden standard to validate ourselves against too. But we do face some of the challenges when we try to use ROS to validate our software, because a lot of times when we derive the URDF from the open source, for example, for different robotic models, we realize that some of the URDFs are not accurate, or actually, this is especially true for more obscure brands, robotic brands in the market. So a lot of times we actually need to go back and redesign, create our own pipeline to generate the URDF that is more effective of the actual robot dimensions. So what we feel is that if there is an official URDF repository that covers a wide range of robotic brands and models, I think that can really help to accelerate a lot of the robotic simulation or development on the market. It could be our lack of knowledge on how to exactly find the correct URDF, but what we realize that different URDF models are scattered in different repository that it's a bit hard for us to find the correct one. Because there are also, for a single brand or a single model, there could be different repositories. Actually, we spent a lot of time trying to validate and cross-check between different models. That was the time-consuming part for us as well. So what we are going to do next is we are going to upgrade the fidelity of the scanner that we use. Right now, the scanner that we use, it have an accuracy of 0.5 millimeter. What we want is to upgrade to a higher fidelity scanners like a PhotoNeo or ARTC to help us to actually do more complicated applications that require higher precision. We already have customers that uses ARTC for welding, scanning of welding parts, but we do want to work with someone that is very familiar with 3D scanning systems to come together to develop a turnkey solution for industrial scanners that actually can help to achieve different complicated use case. So if you're very familiar with 3D scanning, you're also looking for a partner that can help you to deploy in an easier manner, because we already have an interface, we already have the app, and we also, because our app is actually on the App Store already, so all the commercialization, the pricing, everything is set in place already. So the customers just go to the App Store, they pay through the portal, and then the distribution or the how the profits is distributed for the systems that we collaborated and developed, I think that can be discussed later on. Okay, so I think for us in this state, we are very open to collaborations, because I think if we develop everything in-house, it will take a very long time and take a lot of resource. So how easy is that, for example, if you use ROS-I or ROS-II, you develop your own algorithm, or you develop your own optimal process parameters for different applications, or you have a different design of a novel system, we can work together, and Augmentus will be the interface for your own proprietary system that allows you to reach out to the operators or the engineers in the factory environment. At the same time, we offer easier, optimal UI UX, a very interactive user interface for the user to fine-tune and reconfigure the system. We also can offer coordinate frame calculation that you can import into your ROS or RVS environment. And we also allow the user to inject their own API libraries inside So for example, if you have communication with the specific ROS node that is in the custom messaging, then you can actually inject, you can actually write your own API and implement into our solution. You can call and synchronize with your own solution. And we do offer connectivity such as TCP/IP, FTP, and RESTful that caters to your communication needs. So, so this is the end of my sharing. So if you want to reach out to us and for collaboration, for discussion, feel free to do so. So this is my number and my email. And thank you so much for listening.
Hello. Hi, there. Yeah, so we have a 5 minutes Q&A session now.
Maybe a question from me. I'm LJ. I'm the research director at APAC Research. Great presentation. Just wondering for your scan to plan solution, you are now using a RealSense 3D stereo camera.
It's something like a RealSense, but it's not specifically RealSense. I think as we know, RealSense has stopped production already.
Yes.
Yeah. So therefore, we actually pivoted away from RealSense into something similar.
Makes sense. I'm just kind of curious, since you are looking for a higher precision solution, perhaps something based on, let's say, sensor fusion type of product would be probably more applicable to your requirement. Would that be the right assessment?
So we have spoken to a lot of customers before, and at the end of the day, it's always the operator that is the influencer inside the factory itself. So as long as the sensor fusion is as autonomous as possible or as easy to use as possible, actually a lot of times they don't care what technology that we use behind. They just want it to be easy to use. So I think we're definitely open to a sensor fusion technology as long as the customers are have a good reception of it. Yeah.
Yep. No, thank you. Thank you.
What's the entire scope of your solution? Are you using ROS at all embedded in the iOS app? Or if I have an existing ROS-based enabled industrial robot, can I go off to the races and just incorporate this to start controlling the robot? Or is this an entire package?
It's an entire package. During the early stage of our development in 2019, we did have the idea of packaging ROS into a tablet solution. But we realized that the overhead for ROS-I was a bit heavy for us to do that. So we decided to actually create our own kinematics library. We validated the output against the ROS system.
Is it out of the realm of feasible, or to just have an interconnect between like the scanning, the mapping, and the planning is done on the service that you provide, and then the trajectories are then executed via whatever controller I already have?
So the scanning and the planning and everything is done on the tablet. Everything is inside the tablet itself. So the execution of the robot is that we generate the robot-specific code. So ABB is Rapid, KUKA is Corel, UI is URScript, and we will send it into the robot controller. So it can run as an independent script. So it needs to be that way because a lot of times, once the programming is done, then the customer would just want it to run as an independent script. They don't want the external system to be in control anymore.
So these are more like appropriate for fire and forget scenarios. But if I have something that's dynamically changing, or like a human entering the work cell, that's not quite of scope yet.
Yes, correct. Yeah. So I think for human to actually come in, I think it could be a collaboration. So because I think we are very focused on the robot planning and simulation part. We are not so much focused on like like a light curtain or the human robot collaboration kind of technology.